Hi, this is Professor David Farina. In today's lecture, we're going to talk about the solar system, in particular, an inventory of the solar system. Let's get started. So, for thousands of years, people have been looking at the night sky, and they've quickly identified 5 objects in the night sky of vast interest. These things were called planets, also known as the Wanderers. And planets were important because not only were they bright, but they moved through the sky. And this got people interested. Those 5 planets are, of course, Mercury, Venus. There's also Mars, Jupiter, and Saturn. And now we have quite a bit different understanding about our solar system. We have one star, of course, the Sun, and 196 moons. We also have 8 orbiting planets. Of course, Pluto is one of those dwarf planets now. We've got things like asteroids, comets, meteoroids, and even Kuiper belt objects. And not shown in this diagram, something called the Oort cloud. So let's look into this a little more in detail now. So if you'd like to take just a moment here to look over this table, I'll give you a second. Please pause the video. Alright, now that you've paused the video, let's take a look in depth here. Orbital semi-major axis. This is basically like the distance. It's almost like a radius, but when you're dealing with an elliptical shape, an oval shape, there is no radius per se. We call it the semi-major axis. There's also the orbital period, how long it takes to go around the Sun. Notice it's in Earth years. We've got Earth masses in terms of the masses of these planets. We've got the radius in Earth radii for each planet. We've got the number of moons for each planet, and then the average density, once again with the Earth equaling 1. So we're using the Earth as an analogy, or as a comparative planetology, we would say. And this is really kind of helpful because we know a lot about the Earth because we live on it. So once again, you want to stop this video and take a look over the table. I'll leave you a second right now. So we can determine quite a bit based on today's modern technology, our mathematics, and our observations. We can look at the distance from the Sun, and we can mathematically convert to using Kepler's laws to figure out distance. We can find out its orbital period by observing the planet over a period of time. We can determine its radius if we know its angular size. So once we have its distance, if we know how wide it is in the sky, we can get a distance value. We can also get a radius value. We can determine its masses using Newton's universal law of gravitation and the interaction of those planets with other objects like moons and other planets. We can get the rotational period from observations, and finally we can get the density of the objects if we know its radius and we know its mass. So these are the ways in which we can find out more about the planets and the objects within our solar system. This edge-on diagram of the solar system kind of gives you a perspective on the fact that this is a pretty flat disk. With the exception of Mercury, all of the planets are almost perfectly in a disk shape. And this has to do with the way angular momentum works, and how, when we'll talk later about how the solar nebula formation occurs, but basically we have a cloud of dust and gas that's condensing down, and then it compacts into a disk. And that disk is what forms from not just our solar system, but all solar systems. We have 2 very distinct planet types here in our solar system. We've got the terrestrial or Earth-like planets, and those include Mercury, Venus, Earth, and Mars. And then we also have the Jovian planets, which are like Jupiter, Saturn, Uranus, and Neptune. And these 2 planet types have very distinct ways in which they form, and we're going to get into that in another video. So once again, I'll ask you to stop the video and look over the terrestrial versus Jovian planet table here. you can see that there's quite a bit different about these two types of planet. All right, so now that you've had a chance to look over the Jovian versus terrestrial planet table, I'm going to highlight some important facts here. All of these factors have to do with the formation process. So once again, we'll get into that in another video, but I just wanted to highlight that the differences we're seeing in the physical properties of the planets have everything to do with the way they were formed. Now, within the terrestrial planets, we also have a number of various different things that can happen. We have differences in atmospheres and surface conditions. We have differences in the having oxygen and liquid water like Earth has. No other planet in the solar system appears to have the same qualities, which we think are important for life. And Earth as a life-sustaining world, a habitable planet, is something that we're going to talk more about when we get into extrasolar planets, planets outside of our solar system, in a later lecture. We also have differences in the rotation rate of the planet. So Earth and Mars have a very similar rotation rate, whereas Venus and Mercury have a much slower rotational rate, how fast it spins or how long one day occurs. Mars and Earth have moons. Venus and Mercury do not have moons. And then Earth and Mercury have magnetic fields, whereas Mars and Venus do not. So you can see just within our own solar system, the terrestrial planets have vastly different surface and atmospheric conditions. So I hope you enjoyed this video and hope you learned something new. If you like this video and you'd like to learn more, please click that like button at the bottom, subscribe to the channel, and click that bell to get a notification each time I make a video. Thanks again. I hope you have a great rest of your day.